We'll be talking about surface tension. As with always trying to understand something for the first time, you always start in a vacuum and with no outside forces acting upon the object.
So imagine we have a giant blob of water floating in space with no other forces around it. So if we look at the center of here, there will be particles of water all around each other, and they will be interacting with each other. This interaction between similar molecules of liquid, in this case water, is called cohesion. So water has a very high cohesion force, and it's much higher than many other fluids that we have in our Earth, but is not the highest. So these forces are acting upon each other through something called van der Waals force, and so this water particle is being acted upon all these other water particles surrounding it. So water likes each other and it wants to stay together, kind of like a clique. So when these forces are acting together, they form tight bonds, and these water particles stop moving around, like within their little tiny range. So they're kind of in equilibrium here, and they're happy because they are equal. Now when we look at the outside of the water particle, we have something like this. And so the water particles on the outside aren't happy because they have some bonds with the water particles around them, but they have no bonds on the area above them. There's nothing acting upon them here. And so when we get to adhesion, which is the interaction between liquids and solids, this will come into play, where this water particle wants to be happy by being in equilibrium and being surrounded by other water particles. This also, because there are no forces to pull it away, it tightens the water bottle just a tiny bit, not by much, but a little.
So likewise, we can imagine water particles like two fists, and these water molecules are interacting with each other. So they're kind of locked in, like knuckles, but they can still be moved around. And so when another object comes down upon them, it rests upon the two particles. They want to stay together, and so they are able to hold up whatever particles are putting force on them. But if enough force is put through, then the particles will split, and whatever object is coming through will be able to move through the water.
So we have van der Waals force, so it basically what it says is for particles, even for particles that are neutral, much like water or extremely close to neutral, they still have electric charges inside of the molecule itself. And so what these charges will do when aligned with other particles, and this is the force that brings the water particles together, the main force, is that the positive charge will actually rise one way and the negative charge will go the other. And so this will also orient the other particles around it, almost creating a electrical field type of thing. And so this electrical field and this bond between these water particles is what holds them together. So now we have adhesion and the meniscus, which is the effect that water has against sides of surface, or liquids in general, really, and where the water level will actually rise a little bit in here. So like I said before, the water particles want to stay happy, and they want to be equal and have forces all around them. So we have the particles in between here, and then we have the, let's say, plastic particles over here. So the water will form bonds with the other water particles, and it'll form bonds with the solid structure, and we're using the van der Waals force. And so even though that there's gravity acting upon it, these forces that the water has between with the wall actually keeps it up in where it stands. So this also, can explain water droplets, how bigger ones start to fall. it goes as a unit. Many water particles start to flow down, and then they drag each other because of the forces in between them. And then some will stay because they have really strong forces over here, and the forces over here are greater than the forces of the other water particles when they move. And so this also, for the meniscus, explains why it kind of curves and arches like this, because if there was a lot over here, then it kind of just all falls down and the forces aren't as equal. So the adhesion of the liquid will determine how high the meniscus will be, because if there's really great force between the water particles and the fluid particles and the solid surface, then it'll go really high and be able to resist gravity for a very high height. Whereas the cohesion of it will determine, in essence, the width of the meniscus. And while this is always exponentially decreasing, it still is a bit of a difference between liquids. So the adhesion determines the height, and the cohesion determines the width of the meniscus.